Hello, everyone. Thanks a lot for joining. I'm Mohammed, and today I'm going to be taking you through a journey about .NET Core and Docker. So first of all, I'm sure already all of you knows that Docker is like the buzz keyword right now, and everyone wants to learn about Docker. But this is the agenda for our session today, and we're going to be going through every one of these in details. So first of all, we're going to discuss what is Docker in general, and then we're going to be delving deep a bit of the Docker components, which is going to be containers, the images, the Docker file, as well as container registry and what they are. Then we're going to be comparing Docker solution with some older tools that we currently have, like virtual machines, and we're going to see like what's the benefit of VMs and what's the benefit of Docker, and I'm going to do a bit of like results based on that. After that, we're going to see how are we going to be able to have Docker available on our machines. Once we do that, we're going to go through the hello world process for Docker, and then we're going to discuss the process of what's going on in the background when we do this hello world. And after that, we're going to create a small .NET application, and then we're going to integrate Docker within it. So once we build that application, we're going to build a Docker file, and then from that point forward, basically, we're going to run that .NET application from within Docker. So what is Docker? Docker is a container management system. What's that mean? We're going to be delving into more details what containers are, but basically it's like a management system that allow us to have multiple containers or multiple files in a single system. And basically, Docker will allow us to create a lot of applications or creative projects, and we can put them all and create executable version of these applications that we want, and then we can put them in a certain repository somewhere, and then we can directly download this repository onto our machine and automate and run this application directly without us worrying about the compatibility, without us worrying about any configuration that we need to do. All of that is already taken care of by that image itself and by that container. All we need to do is just write the command and automatically run. Docker is supported by Windows, by Linux, and by macOS, and basically by any operating system, modern operating system. Docker is also used to automate and to deploy applications on cloud and on-premise. So Docker is not only available for on-cloud, it's available for on-premise. So you can also create your application within Docker, and then you can create the image, for example, and then you can create your own local Docker environment or container registry on your own infrastructure, and then use it within your own companies or within your premises. So it doesn't really have to be on the cloud at all. It's very flexible, and you can use it basically in any scenario that you see fit. So what is a container? A container basically is an instance of a Docker image. We're going to be discussing what's a Docker image, but for now, let's imagine a Docker image is a class and an instance is an object. So a container is an instance of that class that we have. It's allow us to put inside that image, it allows us to execute everything within that image. So that image will kind of contain all of the bins files, all of the DLLs, all of the third-party libraries that we might need to use, any configuration, and all of these, they're going to be put inside an image, and the container will be able to just take that image with a set of instructions and automatically run that application for us. It allows us to scale a service. So for example, let's say we have a single container which contain our web application. And for example, if we want to scale that web application, all we need to do is just create more images, more containers from that image. And based on our, of course, cloud configuration, it will automatically scale up and down. And lastly, all containers are based on some kind of a minimal OS, and mostly they are Linux. So the nice thing about .NET Core, it's compatible with all of the platforms that we have, and since most of you can have other than Linux containers, but most of the images that we currently have are all based on Linux, so it makes it basically run on every single available platform that we have. So what is a Docker image? A Docker image, in essence, is like the binary files, the dependencies, and some metadata and some instruction on how do we run it. So within our ASP.NET context, it's basically all of the DLLs that we have and those configuration for those DLLs, some of the JSON files, app settings files, and anything related to NuGet. All of these can live within that image that we have. And after that image is all built up and compiled, it lives all of it inside this image. Nothing can come in and out unless we rebuild it again. Images, as we said, they are considered as like a class. So basically, they are the blueprint of any of the containers. So anytime we need to initialize a container, all we need to do is just go to that image and write a certain commands and automatically allow us to create an image out of that containers. Usually, as we said, all of images are based on certain base images. And in our case, for example, right now, we're going to be building something related to ASP.NET. So our base image needs to be the .NET SDK. But if, for example, we are building an application based on Node.js, our base image needs to be a Node image. As well, lastly, in order for us to generate a Docker image, we need something called a Docker file. And we're going to be explaining in details what a Docker file. But for now, all we can say is a Docker file is a set of instructions that allow us to convert an application, or ASP.NET application, from an independent application to a Docker image. It's a set of step-by-step. Everything goes in order. Nothing can go one on top of the other. It needs to be in the right order. And based on these instructions, we are able to create our own Docker image. So why use containers? Containers are secure because, as we have mentioned before, as soon as an image is created, there is no way we can change anything inside that container. All we can do is we can initiate it and we can utilize it. So it's built in with the security in mind. Its applications can run in isolation. So for example, let's say we have our web application, we have our background services, and then we have, for example, some third-party services and our email services. All of these services will run in their own complete unique isolation. Everyone will know it will run in a complete different ports. Every one of these will run in a completely different network, and no one will know, none of these applications will know that there's other applications that will be able to communicate with. The only way we are able to let this application know of each other, and all of the application will know that, oh, there's other application on the same network as I am, is if we define these network processes inside the Docker file, and we let them know that there is other instances of other applications on the network that they need to rely on. But other than that, every single application is by default in isolation unless we tell it otherwise. Portable, as we have mentioned, once our image is created, we can deploy it to the internet, we can deploy it to Azure, to AWS, to our own separate container registry. We can deploy it anywhere that supported by Docker, and we can utilize it anywhere. So we don't really have to worry about the configuration. We don't have to worry about anything. All we need to do is have a certain Docker container which is acceptable for us, and we can actually host it there. Short startup time. So the nice thing about containers is actually once we actually run them, a lot of the process that's going to take to run our application is going to be very fast, because all of the heavy lifting of the application to communicate with the kernel of the operating system, to do all of the wiring, initiate, for example, all of the statuses and all of the ports, this is all going to be handled by the container. The application don't have to worry about any of those. And based on that container configuration, we are able to accomplish all of these. So for this reason, we have a very fast startup time. And lastly, it takes a lot of less disk space. Why does it take less disk space? Let's go with our .NET Core example. Once we want to deploy that application in .NET Core, we're going to have the published version of that application. And the published version of the application is always very small. And that published version, once it's already within the Docker image, the image that we're going to be using, the base image that we're going to be using in order for us to do all of the wiring and all of the commands that will allow us to run this application, is going to be all of the minimal version. So the disk space that's going to take us to run this application is also going to be very minimal. So what's the difference between a Docker image and a Docker container? As we have mentioned before, we can think of a Docker image as the class or the base class that we have. And every single container is an object that we initiate from that class. So for example, let's say we have a class to generate cars, for example. So every time we want to generate a car, that's a container from those. So And every time we want to do any changes to the image itself, all of the container that's actually running is going to be running on the old version. And once we do any changes to the actual image currently, any new containers that are going to be generated, they're going to have the new version of these. So we can have containers which is running an old version of an image and containers running on the new version of image. This can be handled in different ways when it comes to cloud or when it comes to Kubernetes. But in general, once we create a container, no matter what version of the image that is be created based on, it will stay the same. There is no way for us to update a container. The only way, if we want to update all of the containers, we need to kill all of the containers and then reinitiate them, all of them, one by one, in order for us to have the latest version of our images. And this is usually handled by third party like Docker Swarm or Kubernetes or any of those cloud service providers. But for now, let's just think about it that whenever we have a Docker image or we have updated the Docker image, we need to basically remove or kill the old containers and then rerun the instances all over again and create a new instance from that Docker image. Let's go next. Okay, so what is a Docker file? A Docker file, as we have said, is basically a set of instructions that we have. It's basically a step-by-step line of what do we need to do in order for us to have this application and actually build this application. We can see right now that within this sample code on the right-hand side, we can see that we have certain instructions. They are very minimal, and we can see that we have certain keywords which is in red and certain keywords which is in white. So the keyword which is in red are the Docker keyword that the Docker is going to recognize in order for us to be able to, to build that image. And the stuff in white is basically the commands that we're going to be utilizing or the variables that we are inputting to those words so we are able to do it. We're going to create our own Docker image based on that. But just for now, this is like an overview of what a Docker file might look like. Next, so what is a container registry? A container registry, let's think about it as GitHub. So GitHub is our code repository where basically any code that we have, we can just push there. We can initiate, for example, with GitHub Actions, we can initiate a version of our application from there. And we can utilize webhook, for example, to build a version of our application. And then it will allow us as well to pull the code back and basically keep track of all of the versions of our code. Container registry have the same idea. So basically, once we build an image locally, if we want to, for example, to host it somewhere or we want to make it available on the internet, Docker Hub is the GitHub for containers. So once we have that image built, we push it to that Docker Hub, and based on our preferences, if we want it to be available for the public, so anyone will be able to go and browse Docker Hub and we'll be able to see all of the available images, or we can make it private where it's only us and our own organization will be able to check these Docker images and basically utilize them. Another nice thing about container registries are, as we have mentioned before, they can exist anywhere. So for example, we can use Docker Hub, which is provided by Docker. We can use Azure Container Registry, which is provided by Azure and Microsoft. We can use AWS, we can use Google's, or we can even use our own. We can actually build one from completely locally and utilize it. So it's really, really flexible for us to have a container registry. So how does all of these things that we have discussed fit together? It's also very intuitive and very, this graph makes it very easy for us to understand how it does. So Docker files basically is the main instruction manual that we have within our application. So whenever we create our application, alongside that application, we create something, a Docker file. And basically that Docker file has all of the instruction that we need in order for us to create a Docker image. Once we run that Docker file and actually execute, the outcome of that Docker file is a Docker image. And that Docker image, when we actually run it on our own machine, it's actually stored locally on our own machine. So once we have that Docker image, we can actually have two options. We can actually push it to a cloud provider or to any container registry that we want in order for us to host it and utilize it with our servers, or we can actually initialize that Docker container they have here will allow us to have like a 20,000 view overview about what's the process that's going to take us in order for us to go from a Docker file to an actually running application. And just so you know, every Docker container that run out of the Docker images are running in parallel. So we can have a lot of different Docker containers running at the same time based on the same image. So in this slide right here, we're going to be discussing the difference between a virtual machine and Docker. We're going to start step by step from the hardware level all the way up to the application level. So as we can see here, we have the main foundation of any application that we're going to be running is basically the hardware. And the hardware here, we mean that the CPU, the RAM, the hard disk, and all of the networkings that we might have. And on top of those hardwares, we have the operating system. And the operating system, its main functionality at this moment here is to provide a kernel for us that we can integrate with. And the operating system, it can be, for example, Windows, it could be Linux, it could be Mac OS, for example. And the main functionality of this operating system is for us to provide some kernel functionalities. If we take the example of a virtual machine, those kernel functionalities is going to be connecting to the hypervisor, and the hypervisor is what allows us to create a different virtual machine on the main OS. It's the level that will allow us of those guest OS to communicate with the hardware and of the main OS. So the hypervisor is basically like the middleware who's doing all of the communication. So for example, for one machine, I want to dedicate 2 GB of RAM. For another machine, I want to dedicate 4 GB of RAM. For one machine, I want to dedicate, for example, 1 CPU, another one, 2 CPUs, for 2 cores, for example. All of this configuration is being done by the hypervisor, and all of the hypervisor is communicate with the OS kernel, and then the OS kernel basically route all of these requests based on the information that the hypervisor has provided. So after the hypervisor, the next level is the operating system. So an extra added level from the operating system for a virtual machine is the operating system. So let's say we are building a virtual machine based on Windows Server, because we want to run, for example, a .NET Framework 4.7 application. So we need to basically have a Windows Server to do that, and that Windows Server will have to live on top of that hypervisor. So we can see here there's a lot of functionality that's going to be coming in place. So that Windows Server need to be able to communicate with the hypervisor. The hypervisor will need to communicate with the operating system, and the operating system need to communicate with the hardware. So this is not the last part. So after that, we need to configure our new server with the Windows Server. So we need to put all of the configurations, and then we need to install our applications. So all of these needs to go into this certain flow in order for us to work. So we have first the app, then we have the configuration, then we have the OS, then the hypervisor, and then we have the another OS, and then we're going to have the hardware. So we can see that this can be a bit complicated to manage. And this is only speaking about single OS. So let's say we have another application which is purely running on Linux, and we're utilizing, for example, Node.js to build. So we have to do all of this all over again. So we need to create our Linux environment, which could be, for example, Ubuntu. And then we can configure Ubuntu to run with Node.js and install all of these packages. And then we need to install our application on that guest operating system and then manage it from there. And this is, for example, right now, if we already presetted the configuration. So we said, for example, for OS1 or for virtual machine 1, we want 2 GB of RAM. But if you want, for example, for virtual machine 2, we want to have 3 GB of RAM. So what happened if our requirement changed? Or what happened if our machine got updated and we need to provide more RAMs or more CPUs to our application? All we need to basically remove this application or kill these applications and remove the entire process. So we need to remove all of these 1, 2, 3, we need to remove them and then basically reinitiate it all over again and create it. So here we can see the level of complexity that a virtual machine enables us. Another point that I would like to mention here is, for example, we have here for app 1, app 2, and app 3. So within a hypervisor, if we don't have a really specific configuration for networking, these 3 applications will not be going to be able to communicate with each other. And it's going to be very hard to create for us a bridge between them. On the other side, if we take right now to Docker and let's do the same thing, take it from the hardware level all the way up. So we have the hardware and we have the operating system, which is also going to provide the kernel functionalities that we need. And then we have the Docker engine. So the difference between a hypervisor and a Docker engine is the Docker engine here is going to be basically porting the OS kernel to our packages. So instead of managing the hardware requirement, instead of managing the partitioning of different traffic that's coming through, the Docker engine will basically uplift the kernel that we currently have and make it easier for our application to communicate with the OS. So basically, it's going to live like a middle layer between our application and the operating system. So there's not going to be responsible for like hardware allocation, none of that. The Docker engine basically, or the Docker daemon, is going to be basically just taking the instruction and passing it through the OS and executing them and getting back the commands. So on top of the Docker engine, as we have said, we have the configs, and the configs here are basically our Docker files that utilizes that have the instruction or the manual on how we run our application, and then we have our application sitting on top of that. So we can see already that we have one level, which is the guest OS, which is already gone when utilizing Docker. The second step is we are utilizing existing functionality from the main operating system, which is the kernel. Instead of us utilizing a guest operating system and uplifting or utilizing, these skills from that operating system, we are utilizing the one that already the Docker engine is built upon, or installed on. And lastly, we don't have to worry about any allocation when it comes to hardware, because we are directly communicating with us and utilizing utilities as we might need them. So the first thing is like virtual machine. Let's do a quick summary over this. Virtual machines are more heavier because they require a guest operating system and they require an extra level of configuration, while on the other side, Docker is a much more lighter weight for us to create our application. The second thing is performance. As we have said, that the performance is very much limited by the hardware allocation that we actually give to the operating system. On the other hand, Docker has a native performance because it can directly utilize the OS kernel that it has and automatically takes the hardware from there. Virtual machine, every OS requires an operating system. On the other hand, Docker utilizes the main OS that we have. It has higher hardware requirements, which also have covered this. And networking between the two is way easier with Docker because, as we have said before, if we, for example, we create a Docker compose file and we initiate our own network from within this file, it's much more easier for those applications to communicate with each other rather than have to route this communication through the guest operating system and build a network bridge from there. So how do we get Docker set up? Docker is very easy to get it on your machine. All you need to do is go to Docker Hub. Let's visit it right now. Let's open a web browser. So if we go, for example, let's close this. Yeah. So if we go, for example, to Docker Hub, so all we need to do is we need to create our own account. And for example, first of all, once you sign up, you're able to access a lot of stuff, but let's take it from the outside. If we, for example, want to look for .NET SDKs, all we need to do is utilize the search and we are able to find, for example, let's look only for .NET. We can see a lot of images that already provided for us for free on that on there. And then from there, for example, we can see the images that are available. So as we have mentioned, so through Docker Hub, we can see a lot of different images that are already provided for us and we can utilize. So, and all of these images, for example, we can see here on the left-hand side, we have something called official images. Official images means that it has already been signed in by the provider. So for example, from Microsoft, these are official images. From Google, these are official images. So we have a lot of different contributors to Docker Hub that we can actually utilize their images that basically they give us for free in order for us to use. And there's a lot of open source, very good images that we can utilize within our own projects. So after we sign up with Docker Hub, we can download it. And so it's, let's say, download Docker. Agree. And basically, it's a very simple download. So all you need to do is download the application and follow the installation process, next. And once you have downloaded and installed it, I'm not sure if you can see it here, but on the top side of my screen, you can see like there is a small whale icon. And once we click on that whale icon, you can see that you have a green bubble next to it, and it says that Docker desktop is running, which is what we want and what we need in order for us to make sure that actually Docker is running as it should be. Perfect. So once we have this there, now we have Docker 100% running our own machine. So the next step is let us run the hello world command, and let's see how we can, what happens in the background. So let's open terminal. Okay, so from within terminal, let us just type docker -- version. And we can see that we have Docker version 20.10, which is going to be the latest version of Docker that we have, which is what we want, and we want in order for us to make sure that we are running on the latest version of Docker. So the next step is we want to run the hello world. We want to be able to run the hello world keyword. Sorry, the Docker hello world command. So how do we do that? This can be also very simple. Let me open the slide so we can see exactly how it works. So here we're gonna do just Docker run hello-world. So as we can see here, once we have installed Docker, we have to utilize the keyword that will allow terminal to know what are we gonna be running. So this is why we put the first keyword Docker here. And then we are utilizing the run command. The run command basically is telling Docker that we have certain images that we wanna run. And based on that, we are, and expect after that the container name that we want. And after that, we just specify the container name that we want. And after that, basically, what we can do is we can specify which version, because we said Docker images can have versioning. So for example, we can put latest, which means the latest version, or we can, for example, put version 1, and we can use any version that we want. And if we don't put anything, we're just gonna get the latest by default. So for now, we're gonna put Docker space run again to run an image, and then we're gonna put the hello world. And if we click on enter right now, we can see that something has happened. We don't know what happened, and we can see that the actual application of hello world is running through Docker, which is what the result that we want. But we need to understand what happened in the background in order for us to get to where we are right now. So let me reshare my presentation, and we can go through that process. So we can start here on number 1, which is basically we have opened the terminal, and we have inputted the keyword, which is Docker space run hello world, and then we clicked on enter. As soon as we have clicked on enter, that command has went from our terminal to the Docker daemon, and the Docker daemon basically is like a background service which is running on our machine once you have installed Docker locally on our environment. Once we have installed that, the Docker daemon will interpret our command, which is Docker run with the image. Sorry, with the image name. So what's going to happen right now? The Docker daemon is going to check locally on our machine. Do we have a version of this image that the user is requesting? If the Docker daemon finds that image locally on our machine, then it's going to go directly, it's going to load it back into the daemon. It's going to open that Docker image, and it's going to read all of the instruction that has inside, which is provided by the Docker file. And once those instructions are read, it's going to create a container based off that image, and then it's going to return the output back to that terminal. But what happens if that image does not exist locally on our machine? So our local client or Docker daemon is automatically connected with Docker Hub. which is the main container registry that's available on the internet. So what happens if it doesn't find it locally? The Docker daemon will communicate with the Docker Hub. It's going to ask it, do you have an image with the name hello world that I can use? And if it says yes, if we have provided a version, then the Docker daemon is going to say, okay, I need this version of this, this image. If it doesn't have it, we're going to get back a message telling us that we don't have the exact same version. But in our case, we just ask for the latest. So Docker Hub is going to provide the Docker daemon with the latest version. So it's going to download that image from Docker Hub to our own local machine. Once that image is available on our local machine, the Docker daemon will be able to open that image, read the set of instructions that it has, create a container from that image, and then send the output back to the terminal. So this process that we have that we have just went through, for us, it takes, for example, with our very powerful machines, it can take up for like 1 second to 5 seconds to do all of this, unless we are downloading the image, and depending on the image size, that's all relevant to the speed of the internet, but it's very, 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 very fast. So for example, from 1 second to 5 seconds, we have checked for images, we have created a container, and we have loaded it up, and we have utilized it. If we think about this, when it comes to virtual machine, there is no way we are able to do with this amount of speed when it comes to virtual machine. In virtual machine, for example, let's take Amazon. We need to build an AMI, which is an image of a complete operating system with all of its configuration in order for us to get to this level or to this outcome. And that by itself takes roughly around 5 minutes in order for it to build from scratch. But here, it only took 1 to 5 seconds for us. And this is the speed that I was really referring to when it comes to the main difference when it comes to performance between Docker Hub as well as, between Docker as well as virtual machines. So next, we need to jump into coding. So what are we going to do now? We're going to create a very simple .NET MVC application. We're going to run it, and then we're going to add a Docker file into it. And we're going to see how we can utilize Docker and how we can actually build a container for that application. So let's go back to our trusty terminal and let's navigate to desktop. If I can type desktop .NET North, and then basically I'm just going to utilize that. First of all, we need to have, I'm sure all of you know, we need to have the .NET SDK available on our own machine. So just make sure that we have the latest version, so .NET -- version. And you guys are going to see I have version 5.0.202 on my machine. Perfect. I'm going to utilize the .NET new keyword in order for me to create an application. And then I'm going to give it, so we're going to create an MVC application. And I'm going to give it a name, call it .NET. Let's call it Docker sample. Okay, Docker sample. Great. And this should take roughly a few seconds to create. Perfect. And now let's navigate to it. Let's open it with Visual Studio Code. Perfect. Now that our application has opened within Visual Studio Code, let's open our built-in terminal that it provides us. Yes. And the first thing we're going to do is we're just going to run the application and see what do we have out of the box. So .NET build first to make sure that everything is building as it should be. Perfect. And the next step, we're going to put .NET run. Great. Now we have the application running on port 5000. So let's go back to our web browser. And let's go to localhost on port 5000. And we can see we have a very nice, simple application called .NET sample, and we have a welcome message. Great. So what do we need to do now in order for us to add Docker support to our application? The first thing, we're going to stop this application. We don't really need it running in the background. The next step is we need to right-click here and we need to choose a new file. And this new file needs to have this exact same name with the exact same capitalization. So the D needs to be capital, and then we need to type Docker file, and that's it, without any extension, without anything else. And as you can see, after I type Docker file, Visual Studio automatically picked up and gave it an icon, which is a small whale icon, which represents Docker. So once I click on that, now we have our Docker file, which is gonna be basically representing our application. So as we have said before, every Docker image that we have to build is already gonna be based on a certain image. And because we are building a .NET application, we need to build our base image based on a .NET SDK. So how do we do that? So we're gonna utilize some keywords that that Docker provide for us, which is going to be the from keyword. And let's add some comments before that. So I'm going to share this source code with you. If you can find it on my GitHub and you can utilize it from there. So from here, we're just going to put get base image from Docker Hub. Okay, great. So from basically, I'm just letting them know what base image I want to utilize. And luckily, Microsoft provided us with a base image based on the .NET SDK, .NET 5 SDK. So we're going to be utilizing that. So what do we do? mcr.microsoft.com/.NET/SDK :5.0. And then basically, I want to give it a version. So that base image that I'm going to be utilizing, I want to give it like some kind of a name so I can refer to it. And for me, I'm just going to call it as build environment. So this is going to be my building environment to build my application. And if I want to verify that this is correct, what I can do, I can just copy this, for example, and I can go back to my web browser. And if I type here, for example, Docker image, and I can just type this here, paste this here, and we can see that if I go to that link that's provided, this is the official .NET SDK that Microsoft provide on Docker Hub, and we can see here that this is the latest version that they have, which is 5.0, and if I want to utilize the 3.1, which is an LTS long-term support service, I can use as well. And it gives me a lot of like useful information on what type of operating system I'm targeting. If I have, so for example, I want to target a certain version of Linux and my machine is going to live on that, I can do that. But in general, just utilizing the MCR.NET SDK, that should be more than enough. As well as it can give me some samples on how I can utilize different versions of these, which is really good. So now let's go back to Visual Studio Code. And once I have that, the next thing is I want to provide something called a work directory. So what is a work directory? A work directory is, let's think about it like a folder on our machine. So first of all, we have downloaded, let's think about it as a directory on our machine. So we have downloaded the SDK. The SDK is going to be basically installed. And then basically inside that SDK folder that we have created our own folder. We called it app. And basically everything we're going to be doing is going to be happening inside this app folder. We're not going to divert to it. So everything we're going to be doing is inside that app folder. And once we have that app folder available, what I want to do is basically I want to start copying stuff from the actual application that I currently have into the new folder that I have. So let's do a small recap. So we got the base image from Docker Hub, and that image is now available on our machine. Inside that image, we have created a folder where we called it app, and then we're going to copy our application from our machine to that image exactly so we can utilize it there. So what we're going to do is we're going to start by copying those files inside our container, and then we're going to doing some .NET a task in order for us to make it ready. So the first thing, we're just going to add some command. We're basically, the first thing we're going to do is we're going to copy the CS pros file. And I'm sure all of you know what the CS is, which is this file here. We're going to copy this file, docker sample.cs pros, to inside our container and then do a restore. So if there's any packages that we are utilizing, if there is any extra libraries that we have installed that we wanted available on top of the SDK, this step will allow us to have that. So we're going to just copy the CS pros file. And then from that moment forward, we're just going to utilize the copy keyword that, again, Docker provides for us by default. And I'm going to put the star keyword. The star keywords mean that I don't really care about the name of the file as long as it has the extension CS pros. And then after that, I'm gonna put a space, and then I'm gonna put dot forward slash. What does that mean? So the star, as we said, it doesn't really care about the name. All it's gonna take is the extension, look for extension.csapproach, and the dot forward slash, it means that it's gonna copy paste this file from to the root directory of the app folder inside our work directory. So we copied the Docker sample CS approach from our machine to the root directory inside the app file, which is our work directory. So the next step after we copy it, we're gonna do .NET restore. Basically, we're gonna any extra, for example, library that we have there, if we want to restore it to make it available for us, it's a good step to make it here. So we're just gonna utilize the run keyword. The run keyword, basically, we're telling Docker you need to execute this command inside the image. And the command that we're going to execute is a very simple .NET restore command. So now we are giving commands to our Docker image to make it run. So once we have done that, the next step is for us to copy everything that we need inside that container. So again, we're going to be utilizing the same copy command that we have, and then we're going to put dot, which is going to be basically telling that we want to copy everything from our application inside to the root directory inside our container. And once we have done that, now I want to publish my application to that development image that we have. And how do I do that? Again, I'm going to utilize the run keyword that Docker provide for us, and I'm going to type .NET publish. And then based on that, I'm going to put the C release. All of these are .NET keyword. None of them are related to Docker. And -o, which is gonna, what is the output of it? I'm gonna put /app because it's inside this folder. I'm just gonna put it inside the publish folder. Great. So now what I have here, I have the copy, which is basically copying the CS approach file inside the container. Then I'm doing installing all of the NuGet packages that I have. And then I'm copying all of my source code from that file to inside that container, and then I'm publishing it. You might think to yourself, why am I doing all of this? Why am I publishing inside a container and then inside an image and then publishing it inside that image? Why can't I just publish it directly outside? The reason we are doing this inside the image and not directly copying the published version outside is because if there's any compatibility issues when I'm publishing, .NET will be able to figure out which base version that I have, because if we look at line 1, which is say from Microsoft /.NET/SDK, this SDK version that we currently have, is based on Linux. And when we do the publish keyword, it's going to automatically detect all of the requirement of that Linux image. So if it's, for example, based on 64, is it the 64-bit version or a 32-bit version, for example? Is it based for IoT devices? Is it based, for example, for a specific kind of configuration? We never know. So it's always better to always publish it from inside the image in order for us to get the best outcome from that. But this is what going to be, the next step is going to be the exciting part, because after we published it, we don't really need to have all of those files available again. So what we're going to do right now is we're going to create another image, which is going to be the image we're actually going to build. And we're going to be copying everything from that build environment and putting it inside our published stuff from the build environment and putting it inside the latest version, in order for us to have the smallest as possible, the best optimized for our environment and with the latest configuration. So we have a win-win situation. So how do we do that? We're gonna utilize again the from keyword. We're gonna utilize the same SDK. I don't wanna type it again because it's too long. And then after that, I'm gonna create a new work directory from this. So let me add a comment here. So we know exactly what's going on. And here basically creating our publish image from the base image. And after that, I'm gonna just create our new folder, basically within that new image that I have. Also, I'm gonna call it app. And lastly, this is one of the most important keywords that I have, which is copy. A copy from where? If we take a look from where the build environment, this is the exciting part. at least for me. So we're actually copying stuff from the first image that we have created to the new image that we currently have, and we're copying directly from the app publish folder. So we're gonna telling it that you need to copy stuff from the app publish into where? Into the root folder of that new image. So what we did basically here, we created two images, and those two images basically, one of them was our grunt work. We're just like doing all of the heavy lifting, copying stuff, doing all of the configuration, doing all of the restoring of the packages, and at the end publishing a clean version of our application. And the second step is we created a brand new image that we just basically took the outcome of the first image and we copied into it. And after we did that, the last step that we're gonna actually, before the last step, we're gonna specify a port within our application. And this port will allow us to communicate directly within, to be able to make this image available for us on a single port. So for now, I'm just gonna make it available on, let's say, port 80. So I'm gonna put expose, and I'm gonna make it on port 80 for now. So expose means that I'm just exposing a port to outside of the application. I'm specifying that I want to utilize port 80. And the last point that I want to mention here is, right now we have an image, which is the latest image that we have with the latest version of our application, but we need to specify what is the entry point. And as we know, when .NET, when we type .NET run, basically it's gonna look for the same name of, for a DLL with the same name of our application to run. So, but Docker doesn't really know that. So we need to specify this for Docker, which simply we're gonna specify the keyword entry point. And basically entry point, we're telling it what is the command that you're gonna execute as soon as we initiate a container from this image. And we're specifying the command, which is gonna be .NET. And basically here, we're just gonna give it the DLL name. And if we're gonna know what is the DLL name to be 100% sure, we can go directly to the bin folder. And we can see that our DLL, which is the main DLL, is called docker sample.dll. So this is what we're gonna be using. So we're gonna put docker sample.dll. And that's it. Now, if I save this application, perfect, my Docker file is ready. So one thing I would like to add, as we have with Git, we have ignore file. With Docker, we also have the ignore file. So once we said we're gonna copy everything from that image to the, from our root directory to the image, we are copying also the bin file, we are copying also the properties folder, the obj, the .vs code, all of these we're copying, but we don't really need them. So Docker thought of that, and it provided us with a really nice feature. If we right-click as well, we add a new file, and it has a very intuitive name. So we call it .docker ignore. So basically, anything that lives inside this folder. So for us, for now, we're just gonna ignore the obj file, and we're gonna ignore the bin file. So whenever right now we are building this Docker image and we are copying stuff from the our root application to our new image, these folders are ignored. They are not being copied. So great. Now we have our Docker file. Now we have our Docker ignore file. There's one extra step that I always like to do, is specifying a port from within my application. And this basically, it will I want to say hardwire the wiring between the Docker and our .NET application for us to know where exactly what port is it gonna be communicating with. So for us, I'm just gonna put webbuilder.useURL, and then I'm just gonna force port 80 on it, so it will automatically know that it needs to communicate on port 80, and HTTP star port 80. So the reason I put star, because I don't really care about the domain. All I'm saying is you need to communicate on port 80. And for this session, we're not gonna delve into how we can enable SSL for our Docker container, because that's a completely different topic, and how we initiate SSL certificates locally, and SSL for development environment, and how we can do the wiring for those. We're not gonna delve into those, maybe later on, but for now, we're just gonna utilizing HTTP directly. So after we have done this, I think the next step for us is it's gonna be the step that we are always waiting for is creating our Docker image. So in order for us to create our Docker image, we need to go, let's go back to our terminal, and we're going to type the following. So again, we're going to utilize the Docker keyword. We're scanning the CLI that we have a command ready for you. And we're utilizing the build keyword. We're telling the CLI we have a Docker file that we want to build. And then we want to tag it. So we're going to do both ways, but first we're going to tagging a Docker build file, meaning we are giving it a names we can refer to. If we don't do the tag, it's going to generate a long ID, which is also unique, and it cannot be duplicated. But the benefit of having a tag, it's human readable. So for us, for example, oh, I want to refer to application 1, so I put tag app 1, or I want to refer to, for example, to my DB application, I put a tag, sorry, as a DB application. So the tag all makes it really easy for humans to read it. So for this, I'm just going to put Docker sample as my tag. And then the last thing I need to do is put a dot. And why did I put a dot here? A dot here means that the Docker CLI is going to look in the root level of my application for a Docker file and the Docker ignore file. If, for example, my files are inside different folders, I can, for example, put Docker file and the file here, for example, but they're not, because they are on the root level of my application. I just put a dot, and that will tell Docker that, okay, it needs to look on the root level of my application to find the Docker file and the Docker ignore file. And once I have that, if I click on enter, the magic's going to happen, and we're going to go through it one by one right now and see what's going on. So as we can see here, we have Docker is telling us that it's building, and on step 4 out of 11. So the first thing it did is actually pull down the Docker definition from Docker Hub. So it's actually verified that Docker file actually exists. And second of all, what it did is actually check the Docker file and transferred it to a new image. And this new image is still blank. It didn't have anything inside of it. The second step is it copied the Docker ignore. So the okay. It removed it, but let's do it again so we can actually see it. Okay, so the second thing is actually it took the Docker ignore and it copied the Docker ignore from the root folder to the new image, so it knows which file it shouldn't copy paste later on. And then it did all of this. So what, and you might think to ourselves, oh, what is all of this that's doing it here? So here basically it checked that it needs the .NET 5 SDK. So it actually checked locally, building context that, oh, do I have this .NET 5 SDK available on my local environment? No, it didn't. So what did it do? It went, as we have mentioned before, to Docker Hub. It did all of the checking in the Docker Hub. Okay, yes, I have this version. So the Docker daemon on my local machine just downloaded the latest SDK. And then once it downloaded that latest SDK, it resumed working. So after it downloaded it, it has created a work directory, basically the folder inside this new image called app. And then we can see here it's actually copied the CS proj and did the .NET restore to it as we have specified in our Docker file. And then actually after that, it copied everything and then did the publish. And once that's done, it actually copied the latest version of the publish to the new version that we have. And we can see something really exciting here, which has exporting to image. What does this mean? So once all of these have, all of the steps that we have provided for Docker has been completed and every one of them has been finished successfully, Docker got the okay, everything checks out. Now let's actually build this image for the user. So it takes the latest version and do all of its wiring and it creates an image for us. And basically here we can see that it has exported it for us. And then this is the idea that I was referring to. So because we have gave it a tag, it's easy for us to refer to it as Docker sample. But if we didn't, we have to utilize this long ID that it actually auto-generate for us, and no one wants to do that. So always use a tag. And after that, basically it just told us that it has renamed this ID to the new tag that we have. Perfect. So this is the Docker image has been created, and now we want to run it. And this is what we want. So how do we run it? It's very easy. You can use Docker. Again, we're communicating with Docker. Let's clear the screen so it will be better. So we're going to use Docker. And then I'm going to utilize the run command, because basically I'm going to run something. So I need to tell Docker what does it need to run. And I'm going to utilize this input here. So -p. What does the -p means? -p means I want to specify which port that I want to communicate with from the inside that image. Inside our Docker file, we have exposed port 80. And because, as we have said, they run in isolation, we need a way to communicate from our host machine to that Docker image. And the way we do that is we specify a port between our machine and that container in order for the web traffic or the request that's coming through our host machine will be able to direct it through to our image. So for this reason, we put port 80 to port 80. So basically, any requests for localhost from my port 80, let me do it port 80 to 8080, for example, to port 80 is gonna be routed directly to this image, to that port 80. And then I'm gonna just specify the Docker image, and I think I called it Docker sample, if I'm not mistaken. And if I click on enter, just to take a few seconds, and we can see the normal.NET, everything is running on port 80. And we can see here, this port 80 that's happening here is inside that container. So everything running inside my container is running on port 80. But for me, from the outside, communicating with that container, it's communicating on port 8080. So right now, if I go to localhost and put port 8080, and I can see that my application is running directly on port 8080. So the traffic from port 8080 is going directly to Docker Hub. Docker Hub is actually to Docker on my machine. Docker is actually routing that traffic from port 8080 to port 80 to that container in specific. And that routing is automatically done for us by Docker. So two last things I want to mention before we wrap up for today. One thing is, let's say I came here and I changed something in the view, and instead of, for example, the generic one, I want to say, welcome .NET North to Docker, for example. Let me stop this. And if I save this and I run it, if I use .NET run, it's building, it's building, okay, it's running on port 80 locally, which is what I expected. And now if I put localhost, we can see we have our message, welcome.NET North to Docker, which is the changes that I made. But if I go back to my Docker container and I run it through my Docker container on port 8080, and if I go back here and I refresh, I still see that I have the welcome, although I did some changes. Why is that? Because as we have mentioned before, once a Docker image is built, it's set. There's no way for me to change it. Even if I do changes to my source code, those changes are not going to be reflected. The only way I'm going to be able to get those changes is for me to update that image. So how do I do that? It's very simple. All I need to do is rebuild that image. And once I rebuild that image, it will automatically update it. So for example, for now, if I go back and type use a Docker build keyword again, and let's look what's happening. We can see that it's actually going through the entire process of rebuilding everything, because it automatically detected there was a change in the code and it automatically rebuilt it. So let's read what happened. So first of all, it's copied the definition. It makes sure that everything that we have is already there, and it actually pulled down the environment. But we can see here that because it didn't really need to recreate all of these, it just used the cached version from the previous version. But here, for the build environment, it actually redid all of those and it rebuilt it. Right now, if I try to run it, we can see that if I refresh, we have the latest version of .NET North available for us. Great, perfect. This is what we wanted to see. And the last point that I want to mention when it comes to Docker and .NET and all of this, let's say you have a class library that you want to add. It will not automatically by itself be added to your project. We need to do the wiring for it inside the Docker file. So for example, I'm not going to do it right now. I'm just going to like try to give you a quick overview of how it works. So let me go to my Docker file. And let's see here, I have a new class library. Let me create a new class library. So let's go back, and here I'm gonna put not new class lib. I'm gonna give it a name, -n, call it test class. Very intuitive, mail library, mail lib. Okay. So right now I have created a class library, and let's say I want to utilize it. First, I need to, of course, add all of the references. But here, the main aspect of this is that here, before I copy everything, I need to add a copy for that library. So first of all, the Docker file needs to change its location. It should not live inside my main application anymore. It needs to live on the level on top of that. And then I need to copy all of the file, for example, for that class library inside. So for example, it will be mail lib / mail lib, lib.csproj to like this, and then we have to build it. So just make sure that if you're using any class library that you need to do all of the wiring for it, because it will not automatically be picked up by Docker. You need to specify it in your set of instruction. Thank you very much for your time today. I hope this talk has been beneficial for you. If you have any questions, please feel free to shoot them and to write them, and be more than happy to answer it.